First. Good morning, everybody, and welcome to webinar 3. Could we still be on the first slide, please? I'm Emma Deere, and I'm hosting this series of webinars on behalf of the Tree Action Plan delivery team in Natural England, which we've put together with colleagues from Forestry Commission, Forest Research and the Environment Agency. My team gives advice on woody habitat creation schemes to ensure that trees are planted for the best possible location without compromising other nature recovery. If we could have slide 2, please. We've got a few housekeeping rules. All of the webinars are being recorded along with a PDF of the slides and a collection of the recommended follow-up resources. We hope we've managed to iron out the technical glitches in last week's recording, and fingers crossed for a clear run today. Please put questions in the chat or hold them till the question section at the end of the session. Slide 3, please. Now, there's a pretty big announcement on this slide. Unfortunately, due to circumstances, we've had to delay next week's presentation, the final presentation, which is going to be postponed until the 23rd of October, and the invitation will be sent out after this call. We didn't want to confuse anybody in thinking that today's call had been cancelled, so we'll send out the invitation after today's call. So this series of webinars is designed to help us understand the importance of wet woody habitats. In webinar 1, we were introduced to the classification of wet woody habitats and its biodiversity value, and we heard a couple of case studies about re-wetting woodlands and the biodiversity benefits that were realised from doing that. And in webinar 2, we learned a lot about ecohydrology and about how different wet woody habitats form. So today's webinar is going to focus on why do we want wet woody habitats, and I'm delighted that Chris Waterfield from Forestry Commission and Tom Nesbit from Forest Research are going to take it forward. Although we can't cover everything in these webinars, we hope this is a really strong framework covering the issues that you should consider and where you can find more information. Next slide, please. And over to you, Chris, and you're on mute. Excellent. Thank you.
Thanks, Emma. And just in case any of you were thinking you'd lost a day, it's actually the 2nd of October today, not the 3rd. I just noticed that on the slide, so never mind. Welcome everybody, and yeah, my name's Chris Waterfield. I work for the Forestry Commission as their Carbon and Water Advisor in Forest Services. So my main roles are looking at woodlands for water, as you'd expect. I also look to promote the Woodland Carbon Code. This webinar, why do we want more wet woody habitat? Well, for some of you that will be an obvious, well, of course we do. Of course we want more wet woody habitat. We need it. Others will be sort of pondering that question. I hope Tom is going to be able to sort of give a great deal of this the substance to this next hour and a bit. I'm going to do some flannelly bits at the beginning, as is my want normally. So the status of wet woodland habitat in England, it is perhaps the most structurally diverse habitat of high versitile value, and hence priority habitat status, and it has Annex 1 habitats. It would have been the most common wetland habitat until the clearance for agriculture started in prehistory times, for drainage, and now obviously for development. It's now the least common woodland habitat in the UK. And it is the poor wetland relation, really, often excluded from mapping and inventories, and vastly unknown in extent. It's estimated that there are 50 to 70,000 hectares, but only about 200 hectares of bog woodland exist in England. The remaining wet woodland habitat is very fragmented and of unknown condition. Along with that lost habitat, society is seriously impacted by those lost ecosystem services, some of which we will delve into today. And it's estimated that we need at least another 53,000 hectares of wet woodland habitat in England to meet a favourable conservation habitat. So what services does wet woodland habitat provide? Ali, you were going to launch a poll. If you wouldn't mind launching that poll now, just so that we get a bit of information from our participants, that would be fantastic. But it's a rich biodiversity and wildlife associated habitat with edges and connecting habitat. It has strong carbon retention and storage. It has an effective water cooling ability, like trees alongside rivers do. It's effective for managing floods and drought flows. It will clean, a wet woodland will help to clean water, so provide water quality improvements, and it is a valued green-blue space. So moving on, Tom, you're going to take over from now. You can tell my voice has already gone a bit funny, but Tom, if you wouldn't mind taking up, that's it's over to you for the next few slides.
Thanks, Chris, and welcome. I'm Tom Nesbit. I'm based in Forest Research. I head up a group dealing with physical environments. My own background's in forest hydrology, so all things to do with trees and water. And yeah, the remainder of the first hour, maybe just a bit over, just going to go through with you, provide a bit more detail on the different services that wet woodland habitat provide. I'll then touch on some potential disbenefits. There are some to note. I'll then turn to consider how we go about designing, how we go about creating wet woodland, designing and management aspects. And if there's time, we'll touch on a new initiative, well, a developing initiative called the Woodland Water Code that we're in the process of putting together, that has some implications for wet woodland habitat in terms of allowing people to assess, quantify the benefits they provide. So, as Chris mentioned, he listed 5 or 6 main ecosystem services. First one being rich biodiversity and wildlife. And as was mentioned, this is reflected in its why we're dealing with it today. It has a priority habitat. And there are, based on the National Vegetation Classification, we've got 7 known classified types, 3 of them based on willow, grey bay willow, 1 in downy birch, and another 3 alder or ash. And then in addition to that, we've got the 2 Annex 1 habitats, the residual alluvial forest and the bog woodland. So these reflect the biodiversity, the richness of these priority habitats, the woodland. And as outlined in the 3rd bullet point, this covers the complete gamut of plants, birds, invertebrates, mammals, some really important species, many red data species, and other Annex 2 species in that mix. So 129 plant species are only found in wet woodland. 170 key invertebrate species, including many of the crane flies, and some well-known bird species like willow tit, lesser spotted woodpecker, also things like spotted flycatcher and woodcock, etc. So really rich habitat. And of course, that richness reflects the structure and diversity of the habitat. As Chris mentioned, edge habitats are always valuable because you've got that junction between 2 with that added richness as a result. It's really an important role as a connecting habitat. So these wetland features potentially join other woodlands, adding to that richness. But underpinning it, as we heard last week from Ian, is the structural diversity, the multi-layering of the woodlands. and the associated complexity created by the trees, shrub layer, ground flora, and dead woods. And that dead wood, or coarse woody debris, as an additional key role to play in supporting that biodiversity. And another key point we heard last week from Alice, the fact that this habitat's in constant flux. It's responding to the aquatic environment, and it's altering the aquatic environment, diverting flows, etc. So it's creating this mosaic in response to these processes, and that further adds to this rich biodiversity value. Next slide, Chris. Second, an increasingly important service, be no surprise to you, is its contribution to carbon sequestration, retention and storage. Wetlands, peatlands, known for their soil stock store of carbon, but wet woodlands provides, in addition to that below ground stock, is a key above ground stock, represented by the biomass and also the dead wood that it generates. So together that forms a major carbon stock of value for sequestration. Unfortunately, we don't have a lot of data reflecting the relative scarceness of wet woodland habitat, but we can draw on American studies. There's lots of data there on that inset, comparing different woodland covers on swamps in North America, flagging the importance of woodland on swamps in terms of additional above ground biomass and carbon gain. Some numbers there comparing average swamp woodland above ground carbon with open wetlands. Hardly a surprise, you've got this additional trees, dead wood material, shrubs generating this additional carbon. Then another particular strong aspect of this is the recalcitrant nature of the carbon. Sure, you're all aware, you know, go to sort of cleared bog woodlands, cleared previously woodlands on bogs that have been cleared, you can still find that oak wood at depth, that dead wood. It's really a recalcitrant form, a high density form of carbon, adding to the resilience of that carbon stock. And I mean, a misnomer is this view, I'm sure many of you will be familiar with, is that, well, trees aren't good for wetlands. They'll inevitably dry them out and we'll lose that carbon stock. Well, that's not the case in reality. Wet woodland can support continued peat formation. The issue about trees drying out largely stems from our past practice of draining and cultivating peatlands for conifer plantations and such like, and obviously that drainage and then the planting of conifers and the drying out of that is what's driven the loss of carbon on these wetlands, something obviously from a policy perspective is no longer supported. But if provided the wet conditions are there and woodlands can be left and established, then that wet woodland habitat will continue to support that peat formation. There is a bit of a question about the effects, the net effect on greenhouse gases. You'll be aware of the issue about methane, and yes, there is some concern that wetlands can be a sink, well, can be a source, obviously, of methane, and what that overall balance is remains something to be determined. Overall, I think the research to date is suggesting it's probably a net sink if we balance up the nitrous oxides and the methane and carbon dioxide, but we need more data just to check that. So yeah, really important carbon source. Next slide, Chris. Another increasingly important service is the contribution of wet woodland to cooling of water. Obviously, wet woodland, we're talking about that close connection between the aquatic environment and that riparian habitat. And that connection provides a cooling shade benefit, something we're increasingly concerned about, notably with climate warming, rising temperatures in our streams, the adverse impact of that on quite a lot of our freshwater biodiversity, particularly things like salmonids and such like. And we know it's quite straightforward, quite a bit of work done in the past, considering the important role of riparian shade, wet woodland in cooling these waters. And there was a major project, Keeping Rivers Cool, a few years back, that assessed the lack of shade along most of our watercourses in England, and the need for more shade if we're going to be introduce more resilience to climate warming. And it's quite straightforward to model. We have studies as a graph there that shows the difference between shaded and unshaded streams in terms of water temperature from the New Forest. Studied about 15 years ago, showing that there can be up to 5-degree difference in this case on these hot summer days. And there's a number of lines there on the graph. The top one is the ultimate lethal limit. The middle one, the incipient lethal limit for fish, and then the bottom one, the sort of mean sort of tolerance growth, maximum growth conditions for good growth of salmon. So these temperatures that we were recording 15 years ago were already exceeding these tolerance and lethal limits on these hot days. So a really important role and need for shade to help protect these vulnerable freshwater species. And we can use models to predict how much wet woodland habitat, how much shade we need to limit the rising water temperatures. And I've just included there a few statistics that if we wanted to reduce the water temperature 1 degree for an average water depth of 20 centimeters and an average flow of 1 meter per second, we would need to create a kilometer length. So we're talking about a kilometer length of wet woodland habitat. We're talking about needing significant additional habitat if we're going to make a difference for this growing pressure. Next slide. Another service, once again linked to climate, is the issue of floods. You'll all be familiar with the problems society faces, increasing number of people. I think it's now over 6 million people vulnerable to flooding, considered to be becoming worse, and a real issue that needs addressing. And we now have this shift in approach. We've heard about natural flood management, the recognition that we need to do more with natural processes to try and reduce flood risk, as we just can't keep building our way out of flooding in terms of higher walls and raising buildings. So natural processes really is where it's at, and wet woodland habitat has got a key role to play in that. This largely reflects the role of wet woodland habitat, its contribution to what we call hydraulic roughness. It's just a sort of barrier that is presented by that woody vegetation on the floodplain. There's a table of values there, values of well-established engineering term that's used in all these flood models. It's called Manning's N. It's a measure of this roughness. It goes from 0 to 1, and you can see in this table, if you just look at the middle column, normal levels of Manning's N, that it increases with vegetation on the floodplain, particularly the woody vegetation that is more resistant, stands up to flood flows. And yeah, a wet woodland habitat, a well-structured woodland habitat, is going to give you at least 5 times and probably more the hydraulic roughness of grass, of pasture. So a real significant contribution. And the effect of this roughness is just to hold back the water, delay the water. As you can see in the image, bottom right, you get this build-up of material, of dead wood and the trees, and creating this barrier effect that holds back the water. That has the effect of increasing water storage in the floodplain and slowing its path. You'll not probably be able to make out the small graph in the center of this slide, but it shows the relationship between there's 2 aspects there, the tree spacing along the x-axis, and the different colored lines refer to tree size. Basically, this is just showing that the more vegetation you have, the closer the spacing of the trees, particularly less than 2 meter spacing, albeit that also includes things like the shrubs and such like. And then the bigger the trees, the yellow lines, the 30 centimeter diameter trees, the greater the roughness. So it's that complexity of, and we heard last week from Alice about the recumbent trees, they're older, partly prostrate in the ground, and the dead wood that creates this real structural density and roughness that's very effective at slowing flood flows. And lastly, as a result of that slowing effect, in addition to that, trees are very good at deflecting flows, and that creates that channel diversity. So you get in these where you've got these natural systems, particularly in these alluvial woodlands, you get this flow deflection, creating these multiple channels, and also the backwater pools that are in constant flux that have been cut off, and then new ones forming. And that, of course, is really important for creating flood storage and reducing flooding downstream. We don't have much data on the associated effect of how that will affect drought and low flows, but there's a good understanding, if we think through the process level, that retention of water in these pools and channels is quite likely to enhance low flows. You'll get that slow release of water in these dry periods. Unfortunately, we've got almost no data on that, but the process understanding would suggest that to be the case. So not only can this these wet woodland habitats reduce flood runoff, but they could have an important role to play in tackling drought flows. Next slide, Chris. Chris mentioned about water quality. This can be a bit of a sensitive service. Some of you, maybe most of you, are aware that wet woodland could potentially be used as actual water treatment. They are used. We can engineer these wetlands, but we're not really looking at, obviously that's a specialized use of wetlands like reed beds and woodland to clean water, to take and try and manage quite a heavy load of pollutant like effluent from treatment works. That's not really what we're talking about here. We're talking about the while the process is relevant. Obviously, if we use these wetlands in that way, we're not going to that rich biodiversity and other values of that habitat, because they're going to be very nutrient rich and lots of sediment. But as long as we tackle those sources, tackle them at source, these pollutant sources, which is obviously what's happening with regard to farming, and looking at these new initiatives, regenerative farming, such like trying to tackle, reduce, we can do a lot to tackle, reduce these pollutant loads at source. Having said that, we recognise that there's an inherent pollutant load to water from agriculture that's very difficult to manage. There's a limit to how much you can reduce nutrient runoff and sediment just by the practices involved, even with good practice. And that's where wet woodland can come into play in a sort of polishing and tackling that inherent baseline load of pollutant from wider land use activities. There's a plot there you'll see of data for nitrate. This comes from a natural capital ecosystem assessment project that we're involved in, funded by DEFRA, a site in on the Devon-Cornwall border at Bradridge Wood, where we're monitoring the upstream, downstream effect of a wet woodland habitat on pollutant loading, in this case nitrate from agriculture, mix of agriculture and mix of cereals and pasture. And you can see from that plot, the blue line is the upstream, the red line is the downstream. Over time, over a more than a year period, showing throughout that year ability of wet woodland habitat to retain a good proportion, in this case about 40% of that nitrate load. So really important for tackling nutrients, for polishing that water, but also for pesticides, wet woodland habitat. We're not talking again about really high level, if there's high levels of these pollutants, it'll damage that habitat, but that inherent baseline load, that wet woodland habitat can be very effective at reducing that spray drift, protecting the water environment, reducing by excluding and retaining fecal indicator organisms, and most importantly, well, particular importance, reflecting the hydraulic roughness benefit we talked about before to do with flooding, is the associated siltation, the increased sedimentation within the wet woodland habitat, which obviously reduces downstream siltation and improves water quality. That wet woodland habitat can also has a role to play in stabilizing bank sides, reducing that disturbance from activity in adjacent land, and reducing those sediment inputs. Next slide, Chris. The last, certainly the last main ecosystem service I'm going to describe is this blue-green space. We increasingly hear about the importance of that connection, that green-blue space, particularly in our urban locations. I'm sure many of you have heard about forest bathing, Japanese based activity, which is seen as really important for boosting mental health, well-being, and that water woodland connection image picture there showing the richness of that scene, the feeling that you can experience in walking along in these habitats, real value. And in addition to that, as well as these other benefits we've touched on, particularly in the urban locations, creating wet woodland opportunities to create wet woodland habitat with a real value for cleaning the air, noise mitigation, such like. And then, you know, we need the emphasis on improving health and well-being by getting people out into nature. If we think about how best to connect with nature, how people can access it, footpath networks along river systems give us that pathway approach into entry into that landscape, allowing it to open up in terms of being able to experience along that very rich network and pathway. It can really promote the value of wetland and wet woodland habitat, that strength of connection, and you can lose a lot of people. Not the landscape can take a lot of people, so you can still preserve the habitat value, but still open some of these habitats out to particular wet woodland, where you can screen and use the woodland to direct people to along paths that are both protect the habitat value, while at the same time allowing the experience to be gained of that habitat and that very valuable green blue space. Next slide, Chris. So having gone through all these benefits, I'm sure some of you be aware that it's not all roses, that there are some potential disbenefits, and here I've listed the main ones. Important to say that a lot of those are a reflection of the wrong tree on these wetland habitats, and not manage them inappropriately, sort of stemming from past activities of conifer afforestation onto wetland habitats. But an obvious, and the first one at the top of the list there is that is the potential loss and the competition between wet woodland and open wetland habitats. And since we've got such a limited remaining wetland habitat, then there is very limited opportunities to improve, to expand wet woodland habitat onto that very scarce resource as it is. So that's an obvious concern, and the potential impact on those open wetland priority species. Other potential disbenefits, obvious one of excessive shade and cooling. A picture there showing an extreme case of where we plant conifer trees up to the bank size at close spacing. We lose that structural diversity because there's too much shade and no ground vegetation, and resulting in shallow open channels. And can be excessive cooling in some parts, particular upland areas. And then linked to conifers again, some of you are aware of issues about surface water acidification. That's now, I think we're very much on the mend there as a result of emission control policy, 90% reduction in sulfur emissions that were driving this issue. It's mainly related to uplands and arisen because of previous conifer plantations, when pollutant levels were high, and the associated scavenging of that pollutant led to increased acidification. Having said that, we need to be mindful that there are related issues, particularly to do with alder and nitrogen fixation, which can drive nitrification and increase nitrate levels. Much lower than what we're talking about from an agricultural setting, but still potential for more nitrate. So something we need to be mindful of on these oligotrophic waters. Then there's a key issue about the ability of trees to potentially use more water and reduce water flows. Some concern about ability of trees to fix channels and sediments, and then reduce the mobility of these sediments that can be important for little ring plover nesting and such like. So that's certainly there as an issue. And then importantly, that roughness that wet woodland habitat creates can will obviously back up floodwaters, and depending on where this habitat is created, if you've got adjacent assets at risk, housing, whatever, then that could increase flood risk rather than reduce it. And then in the bottom picture, as you can see, a risk of this woody material that creates the structural diversity and adds to this richness of habitat, potentially can get washed out and block downstream structures. So we need to be mindful of that risk. Next slide. This next slide, in terms of those benefits disbenefits just gone through, I thought I would just spend a little time explaining, dealing with the issue of the higher potential water use by woodland habitats, because that's often cited, as I mentioned before, the view that, well, we don't want trees on wetlands because they'll inevitably dry them out because of potentially high water use. As I mentioned before, that isn't necessarily the case. It depends on what you plant and how you plant. And wet woodland habitat itself will support continued peat organic matter formation and maintain a wet site. Part of the issue is we don't have very little data on the water use of trees on wet habitats, but what we do know from the wider understanding of how trees interact with the water environment is that they certainly can use more water than shorter vegetation, and that's particularly the case with conifer woodland and things like short rotation coppice, species like poplar and willow, which obviously are wet woodland habitat species. They can have a potentially high water use. So there certainly is an ability to use more water, but it is primarily associated with conifers and some broadleaf species. In the round where broadleaf species most reduce water runoff is on drought-prone soils as a reflect of the deeper rooting. But in the round, from our understanding, broadleaf woodlands, native species in particular, generally have a similar water use to shorter vegetation, albeit there is the potential for relatively high rates, as I mentioned, of species like willow and poplar on these wet environments because they're adapted to survive on these potentially wetter parts, some of these wetter areas, and therefore they can sustain quite high rates. Having said that, the rates are still significantly less than what there will be from open water. Open water evaporation rates are probably the highest. So on balance, we don't see, although we need more data, we don't see native broadleaf woodland on these wetland habitats posing a risk of drying them out. These sites, as long as you maintain the water supply, with rainfall and not drain them, they should remain wet. We do have an issue, though, as some of you be aware, about planting woodland upstream, so affecting the supply of water to downstream wetland habitats, and that's something we've been addressing, and we have a reasonable understanding. It's very much an issue related to the scale of upstream planting, and it's something that mainly relates to larger scale conifer planting, and it's about getting the balance right in terms of scale in that wider landscape. Next slide, Chris. And then following on from that, getting that balance right, we now have we're just rolling out a new water resources assessment app, something that was developed with the Environment Agency, who funded a woodland and water resources project over the last few years. This has led to a new water resources app, which we're hoping to roll out later this year. This targets vulnerable water bodies, albeit it should clarify that vulnerable water bodies here is linked to water resources for supply as well as environmental flows, but not specifically to wetland habitats. It's working at what's called an integrated water body level, on average about 2,000 hectare size of catchment, and you can select identify where these water bodies have been classified by the Environment Agency. We know where the vulnerable ones are. What this app does is allow us to draw on model data using a model called Joules to predict the effect of woodland creation, upstream woodland creation in terms of water resource. And we can then look at the results of that for individual woodland creation schemes and assess whether that particular scheme is going to present an issue or not, and whether it needs to be amended accordingly. So that's something that's there now. It's not designed at the moment to deal with wetland habitats because it's at scale issues, but potentially it could be expanded and addressed in due course. Next slide, Chris. Okay, that's been a run through, giving you more detail on the these water services that wet woodland habitat provide and some of the potential disbenefits. I'm now going to run through the aspects of where do we want to create this woodland habitat, how do we go about designing it, and how should it be managed to deliver this what we seek is a more wet woodland habitat to deliver these services that we've just been discussing. So there's a lot of guidance out there, particularly overarching guidance is provided by the UK Forestry Standard, but underpinning that is a relatively recent what's called a practice guide, which is entitled Creating and Managing Riparian Woodland. That goes into all these aspects I'm going to be touching on, providing more detailed guidance on how we go about creating, designing and managing these habitats. So I would say that's a must-read, go-to document. And then there's other guides that are out there, in particular just flagged here. There's a previous Forestry Commission practice guide that deals specifically with the management of wet woodlands. Next slide, Chris. So the first and of starting point is where do we want more wet woodland? And as we heard last week from Ian, obviously the first thing that needs to come is the wet conditions, if possible the natural hydrology regime. So we're talking about thinking about where's these wet spots or these potential wet spots in the landscape. We're thinking about restoring these in particular. Where can we recreate these wetlands? We know there's obviously issues. We have to be mindful of existing open wetland habitats and designations, so we need to work around that. But there's lots of opportunities to build on the existing remnants and expand out to create this wet woodland habitat that we particularly need for these various services, etc. So a particularly important location is, surprise, surprise, along riparian zones and on floodplains. That obviously is the wet locations. There was some mention in the first webinar about, well, riparian woodland, is it really wet woodland habitat? Not the best form of wet woodland habitat. I would challenge that and say it's probably our best opportunity, provided that riparian habitat is undrained and true riparian habitat, which we define as the wet land, the wet ground immediately adjacent to the aquatic habitat and directly influenced by it. There's a little schematic there showing the riparian zone. It's that, as I say, that area immediately adjacent. That is a real potentially rich location for creating wet woodland habitat, and probably the biggest opportunity. Yes, where possible, and we heard last week, I think it was, about, or it might have been the first seminar, that we've lost most of our floodplain woodland. no ancient floodplain woodland along an 80-mile stretch of the River Trent, as an example given between Nottingham and the Humber. It would be great, and we heard that there are some opportunities through landscape recovery projects to try and widen that riparian zone. I mean, there's a natural transition between narrow riparian zones where you get into these wider floodplains, opening up, widening it out into floodplain woodland. So these are the locations. Yes, and obvious limit and constrain main river, which affects most of our river systems. So that's something we need to very much be mindful of. But as a result of that, the greatest opportunities are probably along the ordinary water courses, and their riparian woodland is I think where the greatest opportunity lies. And then, yeah, we need to look at where we're lacking wet woodland. We heard about the lack of an inventory, the lack of a map. Well, yeah, that is indeed the case. We need more information, but that shouldn't hold us back. We know where these wetlands are. I'll touch on in a moment about some of the mapping information that's available. There have been previous maps and data sets put together, and we should get more of those. We heard last week from Alice about work in hand on that. So it's about connecting up where we've got these remnants, expanding, connecting up, looking at where we've got adjacent woodland that we can connect with. Where are our protecting priority species that are most threatened, whether it's by lack of shade or lack of wet woodland habitat. Let's focus on those. We know we've got data sets we can draw on in that regard, both for terrestrial and aquatic species. On the matter of flood risk, we've got lots of data sets that point us to where communities are at most risk of flooding, where there's greatest opportunities for natural processes, natural flood management, where societies at most at risk and is reliant on natural processes because we can't there's limits on more traditional methods. And likewise, mentioned the keeping rivers cool data sets. We know where riparian shade's lacking. We've got all this LiDAR data. So these are all resources that are there to point us where to put this wet woodland. And then, yeah, we know we've got lots of data we can draw on from Europe from previously in terms of Water Framework Directive, where there's been assessments of hydromorphology and where the water courses are physically degraded, unstable, where they've been overly straightened. We know where we should be intervening. We can draw on that data set. And then lastly, yeah, as mentioned, to get the most from trying to address the well-known issue over the poor state of our water environment, the problems over nutrient levels. We know we should be targeting those locations to help reduce that inherent baseline load of pollutant that's impacting waters like the Wye elsewhere, in terms of both the aquatic and riparian zones. Next slide, Chris. And as I mentioned, there's lots of maps we can draw on. We've been doing this for a number of years. Last 15 years, we very much push forward the concept of opportunity mapping, using these various data sets that are out there, spatial data sets, to identify where best, balancing the sort of constraints with opportunities. And an obvious source of mapping sources are flood maps. These are already used to highlight opportunities of woodland creation. They receive an additional contribution of £1,000 per hectare to try and incentivise creation of wet woodland habitat in these flood zones. So we know we've got the maps, we've got the additional contributions. We'll hear more on that in the next webinar. So yeah, lots of resources out there. Next slide. So location, yeah, we know, I think we can do a lot. We know where to go. Next aspect is, well, how do we design the woodland? How much do we need? We heard at the start about we need a lot, but how best to go about designing it. And that's where the Riparian Woodland Practice Guide comes into play. It sets out that, yeah, the aim should be to create this natural functioning wet woodland habitat comprising a mix of predominantly native tree and shrub species. And we can use the natural, we heard from Ian last week about, it's all about topography, that directs us to where these wet low-lying places are. We can use the boundaries, a little picture there from Blenheim Estate showing the some of this relic wet woodland, but opportunities to expand within that floodplain stroke riparian zone. Follow the topographic form, but use these adjacent steep slopes to connect with existing woodland, as in that picture. Yeah, something I think Ian and Dan both flagged. Don't get bogged down. Don't try and create a specific NVC type. There's a great complexity in wet woodland habitat. We shouldn't get bogged down with trying to create a specific class of habitat. We just need wet woodland. We need diverse, structural, complex wet woodland habitat. It will take time, but it will evolve. The woodland will do a lot of this in its own right, as long as you control things like deer and put it in the right place. So we shouldn't get bogged down with these complexities and issues about classification, and because if we do that, it's just going to delay and frustrate. As much as possible, thinking about the wet woodland habitat, which I think does present the greatest opportunities, is about extending. Let's not just have little individual fragments. Let's connect. So real opportunity to connect, extend the wet woodland habitat, not just on one side, but ideally along both sides to get the maximum value and the width and richness of that wider wet woodland habitat. Yeah, as I mentioned, don't be limited to the wet woodland habitat. Look at the opportunities to link it in with adjacent habitat to create these networks, or fix adjacent unstable slopes that are causing issues for land management. And then yes, to create this, we'll get the greatest richness by creating this multiple layer canopy. So it's not just trees, it's shrubs, it's the ground flora, it's the mosaic. We want that mosaic, and that will be naturally created. It's difficult to create. Yes, we need to do a bit in terms of initial design, but once you start it off, if you let this habitat and the trees do their thing, they'll create that diversity of structure, deflecting flows and such like. And then, yeah, consider the scale. It's about working at scale. If we're going to make a real dent on some of these bigger issues we've touched about flooding and water quality, temperature reduction, we need to be doing this at scale. We need to extend this wet woodland habitat throughout these landscapes to deliver those benefits sufficiently. Next slide, Chris. Mentioned the importance of the floodplain because that's the wet area. Just setting out a few key considerations here. It is a real challenge because we need to work closely with the Environment Agency. They've got the responsibility for flood management, and a lot of our floodplains classed as main river and are managed accordingly, and limits on planting, creating wet woodland habitat because of maintaining flood embankments, whatever. But increasingly, we hear about the support for making space for water, making space for trees, pulling back the embankments, creating this wet zone that would support wet woodland habitat and allow the richness and structural diversity to be created where it may have less impact on or an actual benefit for slowing flood flows in the right locations. So, I mean, the most valuable we have these existing maps. The most value area we've what's called flood zone 3. So we know these floodplains are all classified in terms of the frequency, probability of flooding. Flood zones 3 is where the floods in a frequency of more frequent than 1 in 100 years. We know where they are. Unfortunately, a lot of them are, well, I say unfortunately, but from a point of view of creating wet woodland habitat, a lot of these are disconnected because of flood defences. So we need to be careful in how we use the maps, and we need to work with the Environment Agency to understand where the flood defences are, and there's no point trying to plant wet woodland habitat in a disconnected part of the floodplain that is no longer wet and won't give you the habitat we're looking for. So yeah, we need to avoid these disconnected areas. Should avoid pinch points like low bridges, which can potentially be blocked and make flooding worse, but also they're going to enhance the inundation and potentially damage the habitat through greater water depths, because these are the pinch points. But as I say, we can, there is river restoration going on. We can try and reconnect, restore. It'd be great to do this a bit more at scale, and maybe in the landscape restoration process this may be possible. Can we create, 30, 50 hectare floodplain woodland? That would be really valuable as a alluvial forest, the seed of a future alluvial forest. But yeah, we need to plant them in the right places. But we can we know where to avoid. We know where these where areas where there's vulnerable to backing up at floodwater, and where there's potential issues of blocking of structures. And then lastly, we need to be careful with how we design the woodland in terms of fencing. That's a key issue. I'll touch on that in a minute, because that can trap a lot of debris, can be a danger. And so we need to be careful how we do that. But there's lots of guidance out there about how you align the fences and structure them to manage that. Next slide, Chris. Buffer areas, that's come up occasionally in the last 2 webinars. Well, buffer areas, they're not wet woodland habitat. This is, these are designed to tackle pollution. We need to be careful here. Yes, the buffer, the UK Forestry Standard sets out a need to create these buffers. These buffers are designed to protect not just the aquatic environment, but also the riparian environment. And they should encompass, therefore, the riparian wet woodland habitat. So they have potential to create that wet woodland habitat within the riparian buffer. But there's also the wider concept of extending those buffer areas onto the adjacent land to perform that additional function of intercepting pollution and such like, slowing runoff from the adjacent land, not only to provide some of the downstream benefits, but also to protect the wet woodland habitat itself. So we need to be mindful of that. So the UK Forestry Standard sets out what we need to do. There's minimum widths there. So whenever we're creating woodland, we should be protecting and potentially creating this wet woodland habitat. Yes, in many cases it's narrow, as some of these pictures show, as reflection of adjacent agriculture and such like. But where it's appropriate, we should be pushing back those boundaries. So rather than just a sort of 3 or 5 metre, then we should be looking at a absolute minimum of 10 metre and 20 metres in most cases. And yes, these buffers can perform a function as long as they're not overloaded. We've got at the same time, we have to, as I said, tackle the pollutants at source, but they are important for reducing this inherent baseline load. Next slide, Chris. Something that's come up in some visits we've had, looking into how we go about recreating wet woodland habitat, is the matter of crossings. This wet woodland habitat's got to fit within the existing landscape, and often we're talking about trying to restore this wet woodland habitat into an existing agricultural setting, whereby there is still a need for landowners, farmers to access land on the opposite side of the stream or river to maintain their activities. And a key need is that access, and that's often represented by fording, and that's real potentially damaging. And often that potential wet woodland habitat is where landowners will use for access, and in the worst possible case, run their access routes right along it, causing the most damage. So there is a particular need for care in the planning design. You need to build in these carefully constructed access points, because they are required, so that you can protect the adjacent planted areas, the new wet woodland habitat, at the same time support the continuation of the activities on adjacent land. So yeah, there's some guidance on that in the practice guide, and then another one, just there's a picture bottom right with a blue pipe. So some of these locations are also used for often used for private water supplies, maybe for livestock, but also for local housing. So these need to be carefully designed and protected as well, to maintain access for maintenance and such like. Next slide, Chris. Species choice. There's quite a lot of information on that. We had last week about the tolerance of different species. Lots of factors to consider here, but ultimately it's about obviously wet woodland species, most typically alder, birch, willow, but there are other species, quite a range of wet woodland species, and we heard, I think last week, about white elm, a neophyte that's got potential as being resistant to Dutch elm and tolerant of waterlogging. So we shouldn't exclude some of these neophyte species and others, but you know, at the heart of it is the native wet woodland species. We know what they are. We can refer to the resources like ESC and NVCs, etc. The practice guide I mentioned, number 8, which describes wet woodland habitat. Natural regeneration colonization would obviously be preferred, but it's probably not something that we can rely on in many cases, because of that absence or very restricted nature of the existing seed source, because we've lost most of our wet woodland. And if we're going to create this richer habitat, we want that diversity of species, we're going to have to plant. So yeah, well, we much prefer natural regeneration colonization if we want to speed this process up and get to the more structured design. Planting, I think, is where it's at. And we should be looking, as I say, I think, for that mix of both tree and shrub species, build that structural complexity, and then let the woodland develop and create that in its own way. We should be thinking about a high proportion of shrub species on the edges, bank sides and shoreline, particularly to manage the intensity of shade, because in some cases we don't, some species like alder will create very dense shade that may not be best for some of the aquatic species. So it's getting that balance right. And then the question was raised previously about alder. We need to be careful about Phytophthora. We mustn't plant where disease, we don't recommend planting where diseased alder are present. And then there's some limits about acid vulnerable water bodies to do with the ability of alder to nitrify, and so we limit the extent of planting of alder in riparian habitat to less than 10%, but that's quite a relatively limited area in vulnerable upland areas. Next slide. Site preparation establishment. I'm sure some of you will put your hands up. Oh, well, you know, there's no role for that in creating wet woodland habitat. Well, there is to a degree. It's all about how long do you want to wait? Do you want to just leave it up to nature? In many cases, it's not going to happen if you do it because the seed source is not there, or with browsing and other pressures, you're just going to be left with an impoverished site with a very light tree cover, and you won't end up with this rich tapestry and mosaic that we're trying to create. So, you know, with a view that there's a pressing need for more of this habitat, and society is facing all these pressures from which could help to be reduced by much more of this, we should just get on and do it. And so there is a role, but it's limited, for some site preparation establishment just to boost that establishment. So rather than wait 20 years for a tree to get its head above browsing, you know, get it established within 5 to 10 years instead. Having said that, there's no role for intensive cultivation. There is potential to hinge invert mounding, localized spot treatment just to deal with the weed suppression and boost that establishment. Certainly no drains. And particularly we need to stop drains back from the adjacent land. Quite clear that's in the standard. Major issue, and that's how we're going to re-wet these habitats, by stopping back the drains. And there's potential scope to realign these drains to enhance that re-wetting, to boost that recovery of the wetness. No fertilizer, pesticide use allowed, or use of stump treatment. And yes, we need to protect these trees if we're going to deal with browsing and such like. But clearly, if we're continue to use plastic, and there's lots of emphasis on non-plastics, but still concerns about the suitability of some of these biodegradable and just materials and how biodegradable they are. If we use plastic, as long as we collect and recycle, that would deal with it. But the main thing is to try and get the trees established as quickly as possible. Next slide. Lots of opportunities within existing woodland. Although the focus is in creating more wet woodland in our impoverished landscapes, in our existing woodlands where we haven't been good at respecting riparian habitats, you'll be aware that the UK Forestry Standard sets out the need to restore these riparian zones, these buffers, minimum widths. Lots of that going on, but we need to do more. We had lots of funding, so quite a lot of European funding, just to go ahead and clear conifers from bank sides. Lots of that done, particularly in Wales and elsewhere. But the money, a full lot of money wasn't there to restore them, to get the wet woodland. And so a lot of these cleared areas remain impoverished, and we haven't got that wet woodland habitat. So more to be done there. And then where we've still got this remaining conifers planted too close to stream sides, yes, we need to clear that. But there's increasing recognition that you know, we shouldn't be whole scale clear fell and then try and restore. There is opportunity to have more managed transition, to thin out where possible, to have that transition from going from 100% conifer cover gradually through to a native wet woodland habitat. It'll take time, 20, 40 years, whatever, but that should be the ambition. And it's probably a much more beneficial path rather than go from 100% shade to zero shade and then struggle with trying to get restore some shade through new woodland. And yes, we need to manage things like conifer regen and such like, and in particular, try and control invasive non-native species. Next slide.
Tom, just before I turn on to the next slide, you've got about 5 minutes.
Yeah, aware of that. I'm going to curtail it in a minute. I think this is the last slide on the creation, designing and management. Oh, I think there's one more on woody debris. So managing wet woodland habitat, it's not just about creating it, getting the design right. We then need to intervene occasionally to nudge it along the right track to get this rich wet woodland habitat we most need. So there's various ways of doing that that's set out in the practice guide. Yeah, we shouldn't be productively managing the wet woodland. There's the odd occasion, there's things like cricketback willow, but in the round we're talking about non-productive wet woodland habitat in these wettest zones. And much should be driven by management objectives. What we're trying to do, what are the objectives, what are the key points of this for this site, what the species we're needing to protect, both from the aquatic and the riparian terrestrial side. We should be delineating this wet woodland habitat as water protection zones, manage it as a long-term structure, and yeah, with this planning to create this desired structure in the long term, and we can intervene with thinning and bark ringing or coppicing to make that happen. And yeah, there is a role for more productive management on the edges. Talked about the buffer to this riparian zone. So there is certainly scope there, but that productive management should be limited to the adjacent land. Next slide. And then I think this might be the last one until I'll wrap up possibly the next slide. Deadwood. Yeah, no-brainer, really important contribution to the habitat value structure and the benefits that we've touched on. We need to retain, we need to create, it's going to take time. Yes, we could try and accentuate, we can fell some trees, we can create more deadwood. So there are some interventions that's covered in the guidance. But we need to be, particularly when we come to the water courses, we need to be mindful that we need consent if we're intervening there. There is a lot of benefits, potential benefits of speeding up the process of woody debris dam formation. There's still a discussion about the merits of leaving it to nature and waiting for the natural dams to form versus constructing these dams to advance the process. There's quite a lot of different things to consider in that regard in terms of stability and risk downstream from potential washout. So main thing is that this should all be part of a plan, and we should match that plan to the site objectives and constraints and opportunities. And there's some hazards and risks to consider, which we know about, and I've flagged here this assessing the risk document that was produced a few years ago by Adept, which outlines those. Next slide, Chris. Okay, well, I was going to, if there was time, last 5 slides was just to describe the Woodland Water Code, just to flag its potential role in helping to quantify some of these woodland water services that we've been describing. I don't have time. I think in the interest of leaving time for more discussion, I'm just going to curtail this. But just to end with saying that, yeah, we've got an ongoing project funded by DEFRA to develop, design and develop a Woodland Water Code. We've developed a number of what we're calling calculators that allow us to quantify the woodland benefits in terms of the water quality improvement that woodland can provide, with a particular link to wet woodland habitat in the form of riparian woodland buffers. This calculator will allow us to calculate the quantify the reduction in this baseline loads and the benefit to water. There's another calculator that can be used to quantify the flood benefit, including the hydraulic roughness benefit been referring to, but also a related water use benefit. And then the shading benefit, which is specifically linked to the wet woodland habitat, a calculator for assessing that. Our aim is to, well, one of our outputs at the end of this year is going to be to produce a version 1 of this Woodland Water Code. Going forward, we very much hope that we can incorporate the Woodland Water Code within the Woodland Carbon Code, and at least initially allow these woodland water benefits to be quantified and bundled along with carbon, and perhaps in the longer term, maybe opportunity to stack those benefits. So yeah, Chris, if you just speed through to the last slide, I'll just end there. Have a look out for the Woodland Water Code. There'll be various outputs at the end of the year, and that will hopefully, for those of you that are interested in the economic value and the potential market for growing these services to further incentivize wet woodland habitat creation, then hopefully that will be a set of tools and resources that will be helpful. Okay, I'm going to stop there, and yeah, hopefully we've got 15 minutes now to consider questions. Thank you.